Hello, everyone. Good morning, dear authors and invited guests. Welcome to Technical Session 1A. Myself, Karthik Bharadwaj, and this session will be moderated by me. On behalf of Global Knowledge Research Foundation, it's my pleasure to welcome you to the 9th International Congress on Information and Communication Technology, ICICT 2024, London, UK. The ninth edition of the conference is being organized by a hybrid mode. The physical event was organized in London on 19th and 20th February 2024, and the virtual event is being held through Zoom today and tomorrow, that is 21st and 22nd February 2024. I hope you will enjoy the knowledgeable and interactive session through the day. In the session, we have six presentations. Each presenter will be given 12 minutes for their presentation and 2 minutes for question answer round. On 10 minutes, I will raise a gentle reminder. There is another request to all the participants to stay connected till the end. If you have any query or update, then you can write it to me in the chat box. Before getting started, I would like to introduce you with the session chair. For today, Dr. Anubhava Jain will be sharing the session. She is the Director of School of Computer Science and IT, IIS, deemed to be University, Jaipur, India. Ma'am, kindly motivate our participants.
Hello, can you hear me, Harsh? Hello, Harsh, is my voice audible to you?
Yes, ma'am, you're audible to us.
Yeah. Hello, everybody. First of all, I thank all the organizing team of the conference, ICICT, and congratulations for organizing such a wonderful conference. And I wish all the best to all the participants of today's session. So let's quickly start with her. Harsh.
Thank you, ma'am. Now, moving towards the first presentation, I would like to call Asad Suleiman Dotam for the paper title A Comparative Study on Two Apple Leaves Dataset Captured Under Diverse Condition. Sir, you can proceed with the presentation.
Hello, good morning.
Good morning, sir.
Okay. Hello, good morning, dear scholars and invited guests. It is nice to meet you all. I am Asad Suleyman Dutum, PhD student at Ankara University based in Ankara, Turkey. Before I start, I would like to thank my supervisor, Dr. Berend Troll, for his support and guidance throughout my research. And also on behalf of my co-authors and me, we would like to express our gratitude to the organizer of this conference for giving us the opportunity to present our research work in front of you all. Today, we will present the result of our research work on a comparative study on two apple leaf datasets captured under diverse conditions. And now we are going to the main presentation. Table of contents, introduction, motivation, objective, contribution, data and methods, result and discussion, conclusion and reference. Introduction, motivation. There are many diseases affect apple trees caused by fungi and bacteria. These diseases affect the leaf of apple, including apple rust, apple black rot, apple scab, brown spot, gray spot, and so on. These diseases spoil the appearance and the taste of apple fruit, which impact on market life by reducing the production and make the consumer dissatisfaction. Therefore, the producer and stockholder are subject to economic loss. Objective. We use Vision Transformer to identify apple leaf diseases from image dataset taken in various lighting situations and evaluate the effectiveness of each method. Choosing Apple dataset, that computer vision transformer, or VIT, researcher would utilize to get accuracy results. There are many diseases do not have outward sign, which need to be carefully investigated. Contribution: classifying and detecting plant diseases more quickly and accurately by using or utilizing deep learning architecture such as vision transformer. The model's performance is significantly impacted by the quality of the dataset. Data and methods. First, we use two public Apple datasets. The first one from Plant Village, and the second one is from plant pathology. Second, data pre-processing. We do data cleaning. Data cleaning is the process of preparing or pre-preparing data for analysis by removing or modifying data that is inaccurate or incomplete or irrelevant or duplicated or improperly. Two, visualizing the data set. That means graphical representation of the data by giving the details of the data set. Third, data splitting. We split the data into two sets. First, training, which is 80%, and the validation 20%. Fourth, data or the trained data set. We're using data augmentation techniques such as image flipping, rotation, zooming, horizontal flip, vertical flip, and so on. Fifth, deep learning model. We use vision transformer to train the data set, which is a model is trained into augmented training data set. Sixth, model evaluation. The performance of the metric used are accuracy graph and F1 score. Data and method. Data set distribution. In the first graph, as we saw, we distribute the distribution of the classes from the plant pathology data set. The second graph in the middle shows the distribution of the classes from plant village data set. The third graph shows the distribution of both data sets. Example of leaf data sets. All right. As we see in this picture, there are three classes: healthy leaf, apple scab, and apple rest. In the second picture shows the classes of dataset from plant pathology or pathology, which are apple rest, apple scab, multi-diseases, and healthy leaves. Vision transformer. This is a model we use to train the data sets. This model transformer, it works as follows. First, we split an image into patches. We flatten the patches, produce lower dimensional linear embedding from the flattened patches. Then we add positional embedding. After that, we feed the sequence as an input into the transformer encoder. So the multi-layer perceptron pre-train the model with image labels. And in the last, the fine-tune classify the data set. Result and discussion. We propose This is a model of the proposed model, as we see. The input shape is 256 times 256 times 3. The input shape. The output layer is 768. The flattened layer, the same thing, 768. And we use softmax as as activation function. Result and discussion. Plant pathology dataset result showing that it has an accuracy rate of 96.82 and the F-score has a rate of 96.83. While the plant villages dataset result shows 99.80 for accuracy and F-score respectively. That means, as we see here, the plant villages dataset is has more performance than the plant pathology. As we see here, this is the graph for the training and validation accuracy for plant pathology datasets. The second graph here, the training and validation accuracy for the plant villages dataset. The confusion matrix for the plant pathology, as we see here, 98% for the healthy, that's the true positive, and the true positive for the rest is 120, and the true positive for the escape is 117. While for confusion matrix for plant villages, the healthy has 325, and the rest 46, and the SCAP is 138. Conclusion. Plant diseases may be classified, determined, and analyzed early on with the help of the automated model like Vision Transformer, which also lower the error and increase yield. Plant villages dataset perform better than the plant pathology dataset. Application created with the plant villages dataset have higher chance of success. Plant villages is better dataset for deep learning architecture because it uses a variety of strategies to build diverse field dataset with varied background environments. This is the end of my representation. And on the comparative study on two apple leaf datasets captured under diverse condition. Thank you very much.
Thank you, sir. Ma'am, any questions?
Yeah, very well presented, sir. Can you hear me?
Yes, can you say loudly, please, ma'am?
Yeah, I just wanted to know why do you think plant village data set is performing better than plant pathology?
Yes, actually, plant villages perform better because they use many technique for the data set, like data augmentation, and they have many technique. They use it.
But can't we use those techniques for plant pathology? We can use those same techniques for plant pathology.
Say that again, please. Hello? Hello, ma'am.
Sir, can you hear me?
Yes, I hear you. Can you say loudly, please?
Yeah, I just want to ask, we can apply the same techniques on plant pathology's data set also, isn't it?
Yes, we can apply, but we are applying, but sometimes plant villages, they process the data set and put it for the public. It's different than the data. Some data set that is not processed. That's the difference here.
Okay. Okay, sir.
Thank you.
Thank you, sir. Can you please remove your presentation?
Thank you. Okay.
Thank you, sir.
You are.
Now we are moving towards the next presentation. For the next presentation, I would like to call Rafat Sarkar Ayun for the paper title A Novel Approach of Making French Language Learning Platform via Brain Computer Interface and Deep Learning. Sir, you can proceed with your presentation.
Hello, can you hear me?
Yes, sir, you're audible.
Okay, I'm going to share my screen. Hello, is my slide visible to you?
Yes, sir, your slide is visible to us.
Okay, let's begin. Hello everyone, I am Rifat Sarkar Ayon and I am one of the author of paper number 418. The title of our paper is A Novel Approach of Making a French Language Learning Platform via Brain-Computer Interface and Deep Learning. And I am going to present this paper on behalf of all the authors. Initially, I am going to discuss why we have decided to do this research. At first, I am going to disclose the importance of learning new language. Well, it is true, artificial intelligence eliminated lots of necessity for learning a new language, but still there are enormous advantages a person may achieve by learning a new language. According to scientific research, it has proved that learning new language enhances anyone's creative and critical thinking skill. As learning language is a time-consuming task, so when a particular person can able to adopt a language by going through this process for a long period of time, then this particular person will adopt a quality like persistency, and persistency is highly essential for any individual to accomplish anything great. Now I am going to tell why I am advocating for French language. Well, first of all, French is the official language of many powerful organizations like European Union, NATO, United Nations, and so on. Therefore, learning French will assist any individuals to get a decent job. Besides, French is the official language of many countries across the world. Even first world countries like Canada, Switzerland, and Belgium recognize French as their official language. So that is the reason French increases appreciation of other people and the culture. Yes, it is true that there are enormous platforms available which are assisting the French language learners, but we have noticed some drawbacks. These platforms are beneficial to enhance the level of vocabularies, but it is quite difficult for any particular person to keep memorize lots of vocabularies without having any conversational partners. And it is language learning is a time-consuming task. Therefore, it is highly essential to keep motivated for a long period of time. But it is quite difficult for any individuals to stay motivated this task for lots of time. Therefore, we have decided to design a platform for the French language learners by eliminating such drawbacks which I have mentioned right now. Now I am going to tell about our research objective. First objective is create a French language learning platform via brain-computer interface and deep learning. Well, as I mentioned already, that language learning is a time-consuming task. Therefore, without staying motivated, it will not be possible to adopt this language. That is the reason we have decided to design our platform so that people can learn this language by reading articles. And indeed, people love to read such articles which are interesting to them. To figure out the preferred types of articles, the brain waves of the users will be utilized. That means we have trained our model to detect emotion by a brain signal. So when a person get his preferred types of article, then this particular person will find interest to read this article. And along with every article, its corresponding French translation will be available. That is how a user simultaneously read articles and learn French at a time. Yes, I have already mentioned that it is quite difficult to find out a French-speaking person in a non-Francophone country. Therefore, we have decided to add a virtual conversational partner to practice French. In this slide, I have presented the process sequence of our research. Initially, we have focused on data collection pre-processing. Following that, training was completed, and afterwards, the chatbot was included. And eventually, we organized our platform according to our plan successfully. First of all, we have collected data. Data is the fuel of training artificial intelligence model. As our motive is to train a model to detect emotion from the brain signal, therefore we have collected data from online where the information of every brainwave and the corresponding outputs available. There are total 2,549 columns available, and except the last one, all of the columns are labeled as input, and the last column is labeled as output. After completing the task of data labeling, we splitted the data. There are 2,132 data available in our data set, and 70% of the total data allocated for training and 30% allocated for validation purpose. And in this slide, I have also given a pie chart where the percentage of data distribution is available. In this data set, 3 types of outputs are available: negative, neutral, and positive, and label this data as 0, 1, and 2 respectively. After completing the pre-processing task, we initiated the training task. We trained the model using 3 deep learning algorithms. These are LSTM, BiLSTM, and GRU. Among them, BiLSTM performed best. Therefore, we have given the model summary of the BiLSTM in this slide. Here it is visible that there is no non-trainable params available and 5 layers available in BiLSTM model. As well as I have also given the output shape. Now I am going to tell about our process of set up the platform. There are 3 types of page will be available. First one is newsfeed page. Second one is preferred category page, and third one is chatbot. In the newsfeed page, articles from all category will be included. To accomplish such objective, initially we assign a Python list where where all categories name will be available, and randomly one of them will be selected by a built-in Python library, and send a query to fetch article from this particular query to the ChatGPT, and article will fetch by ChatGPT from ChatGPT by ChatGPT API. After fetching, this article will be added to the newsfeed, and users will see this article along with French translation. That is how our platform will assist the user to learn French. There is another page available. It is a preferred category page. In this particular page, the user will see his or her preferred types of article. To do this, when a user reads articles in a newsfeed page, then a user likes this article or not, it will be detected by the brain signal and our trained model. If any particular user like articles, then actually positive. If the brain predicted signal is positive or neutral, then these will fall under the category of like. At the case of negative, these will fall under the category of dislike. In the preferred category page, user will see those articles from those categories which he likes 50% or more articles these categories. So that is how the user will user will get the articles in preferred categories which he liked. So that is the reason the user will stay motivated to language learning tasks, because in this page the user will get
Sorry
his
to interrupt,
type
sir,
of
but you
category.
have 2 minutes to conclude.
Okay. And to practice this French, we have included the chat board. But in chat board, user will give input both in English and French. Then they will get the output, and along with output, the corresponding French translation output. French translation of the output will be available. That is how the chatbot will assist the users. In this page, the performance of accuracy is given. Here it is visible that BioLSTM perform best among all of these in terms of training accuracy, but in terms of validation, LSTM is slightly better than BioLSTM. The scenario is similar at loss sector as well. As BioLSTM perform best, that is why I have provided the confusion matrix of BioLSTM. Here it is visible that the maximum prediction of BioLSTM is accurate. So thank you, everyone.
Thank you, sir. Ma'am, do you have any questions?
Hello.
Hello, ma'am.
Yeah. Sir, what are your future plans to carry forward this research?
Actually, I want to my business, my plan is to make it a business product so that people can be benefited. It is just a proof of concept. So one day, my plan is to make this as a business product by consistently developing this sector. That is my ultimate plan.
So, how much time will it take to launch the first version of this platform?
Actually, it depends up to the instrument. Actually, if any instrument cannot, if I don't found an instrument that is able to fetch accurate brain signal, then I will not be able to make it a business product. So it depends up to many factors as well.
Okay. Okay, sir. Thank you.
Thank you, sir. Sir, I request you to kindly unshare your screen. Thank you, sir. Now moving towards the next participant. For the next presentation, I would like to call Just Lady Astrid Parada Segura for the paper title Comparative Analysis of the Income and Wealth Tax Systems of Argentina and Colombia, an approach from the perspective of international taxation and evasion. Ma'am, you can proceed with your presentation.
Hi, good morning.
Good morning, ma'am.
Comparative analysis of the income and wealth tax system of Argentina and Colombia, an approach from the perspective of international taxation and evasion. Income and wealth tax system are key tools for governments to raise the funds needed to finance their public policies, especially for Latin American and Caribbean countries with a fiscal focus. However, tax evasion and international taxation pose significant challenges to ensure fair and efficient collection. And this article focuses on analyzing the income tax system of Argentina and Colombia through the mechanisms of international tax planning applied to tax evasion and the existence of tax havens. Through mixes research that brings together literature review and fieldwork, a qualitative approach and inductive method using content analysis as a technique which results and correlation of categories that allow establishing that Argentina and Colombia have a lower taxation than the object average. Was tax revenues are equivalent 33.8% of GDP. Introduction. The tax system of Argentina and Colombia have been the subject of much discussion and analysis in recent years. In Colombia, for example, the tax burden associated with the income tax of salaried individuals has been extensive analysis with a focus on reducing evasion and promoting compliance. But countries have implemented various tax policies and regulation and aimed at promoting economic growth, reducing inequality and improving overall fiscal stability. Similarly, Argentina has implemented various measures aimed at strengthening its tax and custom administration, including the establishment of possible collection measures. Tax evasion is a global phenomenon that undermines the ability of states to collect the necessary revenue. Quality methodology. This research is evolving through a quality comparative approach to analysis to the income and wealth tax system of Argentina and Colombia, focusing on tax evasion and international tax system. The quality and comparative methodological paradigms are approached in scientific research in social science. The first aims to inquire about a social reality, and the second, especially in the political and fiscal. The construction of the article is approached through 4 phases composed of a systematic literature review, a collection of that data, examination of similarities and difference, and comparison of the tax system of the countries. Colombia and Argentina income tax in taxing on income are not be individuals and companies each year. In Colombia, the marital status of the person is not considered. This is one of the characteristics in which it differs from the Argentina tax system in income for individuals. As for income tax for corporations or legal entities, as it's known in Colombia, and income tax for corporate entities in Argentina. During the income tax system of Argentina and Colombia share many similarities, but they also have some difference. Income tax is a tax on income earned by individuals and companies. Tax rates and brackets in Argentina and Colombia vary according to the level of income earned. In Argentina, the tax rate for the applies to individuals earning mark Argentine per year. Deduction exceptions and credits are available in both countries. Tax system to reduce the amount of income tax due. In Argentina, deductions are available for items such as medical expenses, mortgage, interest, and charitable donations. In Colombia, deductions are available for items such as pensions, contributions, health insurance premiums, and dependents. Tax credits are also available in both countries. Wealth tax is a tax levied on a person's net worth, which includes all assets and liabilities. In Argentina, the wealth tax was reintroduced in 29, why the objective of increasing tax collection and reducing income inequity. Both Argentina and Colombia offer exception and deduction for wealth tax. In Argentina, there is a deduction for debts, mortgages, a tax paid on real estate and personal property. In Colombia, there are exceptions for individuals and deduction differ between the two countries. Evasion is a phenomenon that occurs in the common tax system in Argentina and Colombia. Tax evasion refers to the illegal practice of not declaring of under declaring income to avoid paying taxes. Taxpayer often use common techniques such as deporting income, overstating expense, and underreporting assets to evade taxes. The analysis of the data provide reveals that both countries have income taxes applied to both individuals and companies. Argentina has a maximum rate of 37% for individuals with income over. Deduction exception and credits are available in both countries' tax system to reduce the amount of income tax due. In Argentina, deductions are available for items such as medical expenses, mortgage, interest, and charitable donations are available for items such as pensions, contributions, health insurance, premiums, and depends. Argentina and Colombia have made efforts to attract foreign investments through various measures related to international taxation.
Thank you, ma'am. Ma'am, do you have any questions?
No questions.
Okay, ma'am. Ma'am, can you please unshare your screen? Thank you, ma'am. Now moving to the next presentation. For the next presentation, I would like to call Belinda Mutnu for the paper title Factors Influencing Quantum Self Technology Adoption and Monitoring Diabetes. Ma'am, you can start with your presentation.
Okay. Mm. Mm. Is my screen visible?
Yes, ma'am, your screen is visible to us.
All right. Good day. My name is Belinda Mutunu. I'm the lead author in the paper titled Factors Influencing the Adoption of Quantified Self-Technology in Monitoring Diabetes. The presentation outline is as follows. I'm going to give you an introduction, then the problem statement, the methodology, the results, conclusion, and future works. Okay. The objective of this paper is to identify the factors that influence the adoption of quantified self-technology in monitoring diabetes. Quantified self-technology is also known as life logging, also known as self-tracking, also known as self-monitoring or personal informatics. It is a technology that facilitates the tracking of biological, physical elements, environmental data, individual mental states, or behavioral elements by oneself using either wearable technology, mobile health apps, or other digital tools. So this quantified self-technology is used to collect, analyze, and maintain data that can be used by diabetics to better understand their bodies. The main problem that we're dealing with here is diabetes. Diabetes is an incurable, non-communicable, and lifestyle disease that affects millions of people worldwide. The management of diabetes requires regular monitoring of blood sugar levels. Thus, for diabetic patients, proper and timely data collection is a necessity of vital importance. Hence, we're saying quantified self-technology presents an opportunity where diabetes can be monitored efficiently and effectively. The gaps in literature so far, existing reviews are mainly in the medical field and in the computer science field. The medical space has focused on the clinical experience of quantified self-technology in improving health outcomes and managing chronic diseases, as well as adherence behavior, such as adhering to diet, exercise, etc. In the computer science field, the main focus has been on the design considerations to evaluate self-quantification technological interventions. In the information space, which is my field of study, the reviews focusing on the adoption patterns and the factors that influence the adoption of quantified self-technology are lagging. Thus, the aim of this review is to investigate the factors that influence the adoption of quantified self-technology by diabetic patients. To identify these factors, the inquiry was conducted as a systematic literature analysis. So the PRISMA approach was followed to answer the research question, what are the factors that influence the adoption of quantified self-technology in monitoring diabetes? We reviewed papers between the years of 2018 and 2023. The papers were extracted from 5 scholarly databases. At the end, after extracting a different number of papers, we remained with 47 papers that we analyzed in depth. In our analysis, we found out that most studies were mainly from Europe, that's 51%, and Asia, 32%. Other continents, such as America, 13% were the number of studies that we found from it. Oceania, 4%. In Africa, the study area is still in its infancy. Quantitative methodologies were the mainly used approach, and most of the studies had no theoretical underpinning. Thus, at the end of the day, a total of 6 main factors influencing quantified self-technology were identified. These factors are as follows. First one is the user characteristics of the diabetic patients. User characteristics now refer to the traits and qualities of the diabetic individuals who's interacting with the quantified self-technology. Under this main factor, we had sub-factors like the participant's age, the participant's level of education, awareness of the medical technology, where we found out that elderly adults might find it more difficult than younger adults to learn new technology because they might face physical and cognitive challenges, whereas young individuals are more auspicious towards technology and are more willing to use it. When it comes to level of education, we also found out that people with higher levels of education have higher patient empowerment and can better understand technology strategies used in self-management of diseases. Under awareness of the technology, we found out that users who are more aware of the existence of the technology are actually going to use it. If you don't know that a certain technology exists, it is impossible to use it. The second main factor was technology preparedness of the diabetic patient. Technology preparedness is the capability of the individuals to use new technology effectively and effectively. If you are not prepared to use a certain technology, it is difficult to adopt it. So how do we make these people be technologically prepared to use a technology? There are various sub-factors such as inclusiveness. Inclusiveness incorporates things like training the diabetic patient towards using the technology, telling them about the benefits of the technology, security concerns they might have. We also have access to resources. If you do not have access to the resources that are required to carry out quantified self-technology activities, such as a smartphone, internet access, even the quantified self app itself, it might be difficult to actually adopt the technology. Under the third, we had social norms. Social norms now, this reflects to how a user's behavior towards technology might be influenced by the opinions of their family, friends, and superiors. Thus, there is a need to study how people are influenced to either adopt quantified self-technology or not adopt it based on their relations with other people. The fourth factor we found out was the service quality of the medical applications. Now the service quality elaborates that this now is a measure of the difference between what people want and how they feel about the service that they are going to get. Under this main factor were things like ease of use of the technology. So now a user's perception of how simple this quantified self-technology is might actually influence them to use the technology. Also, the usefulness of the technology. If the diabetic patients find out that this application or this quantified self-technology is valuable to them, it's useful and offers new services to them, they might actually be willing to adopt this technology. We also have security concerns. Under security concerns, we have things like data misuse, remembering that quantified self-technology is collecting data about a person. This information can actually be private information about that person. So now there are data privacy concerns that are involved. The data that can be obtained by these technological tools might be quite delicate and disclose details that the person would not want other people to know about. If consumers, especially the diabetic patients, feel that this quantified self-technology exposes their data, they will not adopt it. Also, there is data misuse under these security concerns where unauthorized access to personal health data collected by these quantified self-devices may be misused by malicious individuals or hackers, such that a successful data breach could result in the theft of personal health data, which can be exploited for various purposes, such as identity theft and fraud. So these were the main factors that were identified in our review. In conclusion, we say that the most prevalent drivers and obstacles to adoption were the user attributes of the diabetic patient, technological preparedness of the diabetic patient, the social norms, service quality of the medical applications, and the security concerns. So now future research can consider the development of a conceptual framework. This conceptual framework now needs to be tested using a specific context. For example, an African country, since most of our studies were emanating from Europe and Asia, an African country might present new factors. Thank you.
Thank you, ma'am. Ma'am, any questions?
Yeah. Hello.
Yes. Are you saying something? I cannot hear anything.
Now can you hear me?
Yes, I can now.
Yes. So I'm asking, out of all the drivers that you have studied, which is the most important one?
Technology preparedness is the most important driver from what I found out. Remember, in technology preparedness, one of the things I mentioned was inclusiveness. Inclusiveness requires now training those people about the app, telling them that there is a technology that actually exists that might actually help you in monitoring your diabetes. If people don't know about this technology, they actually don't even know how to use this technology. And maybe they've got concerns regarding this technology. For example, security concerns, or if this technology can be beneficial to them, they will not adopt the technology. Also, under technology preparedness, we need to understand the resources that are involved in adopting this technology. If the person does not
Can you
have
tell me
the
one thing?
necessary,
Just a minute. I'm
yes,
interrupting in between. With the increased usage of IoT, I think people
yes.
are now already technology preparedness, right?
Mhm.
So, in South Africa, what percentage of people do you think are still not ready to adopt technology?
Sorry, I'm not getting you.
I'm saying that with the increased use of IoT, people have
Mhm.
already accepted technology, isn't it?
Yes, they have.
So, what percentage still do you feel needs to be aware of the technology preparedness?
All right. This study, although I'm a student in South Africa, but I'm carrying out my study in Zimbabwe. So what
Okay,
I found out in technology preparedness, the cell phone penetration rate is actually different for a country like Zimbabwe. Access to
okay,
resources in Zimbabwe might actually be different. And the response rate, remember, this is introducing technology to help people manage their diabetes. Already, Zimbabwe faces different challenges that affect it compared to other countries. For example, under the World Health Organization, 1 is to 10 people needs access to a doctor. But in Zimbabwe, the numbers are completely different. So we're saying, let us help diabetic patients instead of them every time going for visits to the hospital and not getting the necessary and adequate help they might be looking for. Why not also introduce technology to them?
okay. Thank you.
All right.
Thank you, ma'am. Now, moving forward for the next presentation, I would like to call Sornitsa Yodanova for the paper title Navigating the Digital Horizon Emerging Technologies in Value Added Text Management. Ma'am, you can proceed with your presentation.
Hello, everyone. Thank you very much. I'm still not able to share.
Yes, ma'am. I'm just removing my screen. Now
Okay,
you can
thank you
share.
very much. Yeah, thank you.
Thank you, ma'am.
Okay, so just let me know if you can see my screen moving.
Yes, ma'am. It is visible to us.
Okay, great. So, hello, everyone. My name is Zurnita Yordanova from the University of National and World Economy, Sofia, Bulgaria. And today I'm going to share with you my research on navigating the digital horizon, emerging technologies in value-added tax management. Basically, because the topic is rather new, even though emerging technologies are already in use a lot in any kind of business processes, automations, data analytics, blockchain, AI, and so on. Still, for in the financial sector and specifically some highly regulated topics like, for example, VAT, value-added tax management, they're still rather new for all these technological topics. Basically, it is bibliometric analysis just to kick off the topic and show us the overview of the main technologies already in use. Value-added tax in general is a type of tax that is imposed at various stages during the manufacturing and distribution process. So that's why the topic is so significant for any kind of businesses globally. This tax is based on consumption and it contributes to the complexity and intricacy of its management. So therefore, it is critical for enterprises to effectively handle VAT in order to ensure compliance with tax legislation and also to minimize financial efficiency, especially with the increasing complexity nowadays coming with the global trade and globalism in general in business that we can see. So during the literature analysis, we looked at the digital transformation of VAT management. And to be honest, the literature advancements are yet at the very low level of their advancement. So digital transformation is at the really very beginning, only in the digitalization phase. So there is still no transformation for most of the processes. And also we looked at the role of technology in VAT management, the evolving landscape. The research design is based on bibliometric analysis, and namely we used our software, BiblioShiny package, for making analysis on the data sets that we found in the Scopus database. I have a slide later on explaining exactly the keywords that we include in our data sample. Generally, we did analysis on thematic analysis, evolution analytics, and we present results and some discussion and conclusions to have this clear overview. And we also had some clusters. This is the data selection. So basically, we included first, based on other previous research, we find out that just using emerging technology as a keyword actually doesn't work for really reaching the appropriate, suitable research that can give us insights on this evolution of emerging technologies. So that's why we based our keywords on the main emerging technologies, not only in use for management purposes or digital transformation, but also based on previous research that show us that these are the main emerging technologies that researchers and scholars have been researching in the last 10 years. So these are artificial intelligence, big data, OCR technology. OCR, by the way, specifically for accounting and tax management purposes, artificial intelligence in its abbreviation like AI, Internet of Things, robot, RPA, 3D printing, blockchain, virtual reality, augmented reality, data analytics, and general technology. We try to limit only articles to the business area because related to tax, not only VAT, value-added tax, but to tax, actually most of the results are related to cleaner production, some sustainability and eco-innovation topics. So this is why we just limit our observation on management and business articles and data set. Generally, there are a lot of technological barriers yet, and most of them are from organizational perspective. The traditional sector of managing VAT is still restrictive to involving emerging technologies. So this is why we also gave some recommendations in the end. Basically, these are the main clusters that we found in the domain of VAT management when it comes to new technologies in use. And I'm directly going to the results. Our co-occurrence network analysis based on titles, unigrams offers valuable insights into the thematic landscape of scientific literature. By examining the frequency of word co-occurrence, this approach reveals associations, thematic clusters, and emerging trends within the research domain, in our case, VAT and emerging technologies in use and in research in progress. Key concepts emerge through central and frequently co-occurrent terms, forming the core themes around which this research covered. And just to mention that our final data set is, after all these clearing procedures, is based on 80 articles that all met our searching criteria. I'm going to present you now one of now, just a second to move the slide. I'm going to present you now the Can you hear me? Sorry.
Yes, we can hear you.
I'm not sure I can move the slides. Do you see my results? Excuse me?
No. You have moved to the second slide.
To the second only. Okay, so this is maybe that view. So this is the data set that I was sharing with you, and the results based on the organizational and technological barriers. The insights show us that taxation dominance is the main criteria for involving any kind of technologies. Also, supply chains and economic analysis are the second, and only after that, emerging technologies are in the core of such a research. Basically, these are the main clusters that we found, and we can see that the tax technology domain is already formulated by several of these 80 research in our data set. Most of them are related to growth, to revenue growth and modeling. Those that are more value added and tax related are oriented to the effectiveness, to the impact and policy. Even though most of the research is on micro level, so it actually looks into the single entity, single company perspective. When it comes to technologies, I have some results on the further slides, but still Most of them are surprisingly not related to artificial intelligence yet, but to blockchain and data analytics and big data. But looking more in details into the data, we found that this is mostly because AI in its current trendy usage is actually used in the last 18, 20 months. Most of the research maybe that is developing at the moment is still not published. These are the development core topics that we found, and some distribution. We found value-added tax as a motor theme, so this is quite developed so far. And basic themes, they are all related to digital economy, taxation, blockchain. This is the blockchain technology is actually the one which is the most researched in the literature. And the niche themes, they are related to some incentives, policies. So this is what we identified as a big literature gap, that still there's no incentives from policy perspective that can actually give guidance to companies from government perspective and from regulation and legislation perspective to use or not emerging technologies, and what would be the impact of this. When we looked into the evolution analysis, we can see that even though we had one or two really old articles in our data set, we kept this because they still analyzed some technologies when it comes to managing taxation and VAT in particular, but still they were really a few, and most of these papers, like more than 90% of them, they are in this last 5 years from 2019 to 2023. And most of them, because VAT is an European domain, mostly because it started from the European Union incentives, and now it's distributed all over the world. So that's why we had this cluster of research related to European taxation management. Services, of course, because the complexity of value-added tax there is the most, and the current barrier challenges.
Yeah, please stick to the time. I think already the time is over.
Oh, okay. So this is my last slide then. So our critical observation is the lack of a real discussion about using artificial intelligence, data analytics, and robotics, including RPA, to automate VAT management, and addresses the increasing complexity in its governance. So we call for urgent research in order for all these businesses to be able to address these serious topics.
Okay. I think she has summed it up very well. So there are no questions asked.
Thank you.
Thank you, ma'am. Now we are moving towards the next presentation. For the next presentation, I would like to call Yusra Rajabali. Ma'am, you can proceed with your presentation. I think so. She's facing some network issue. It's okay. Let's move toward the closing remark. I sincerely thank our authors for their excellent presentation and contribution in this session, and all the participants for being a part of this international conference. I hope this session was informative enough. On behalf of the whole team, thank you for the support in this ninth version and on the previous eighth version of the conference. We will be happy to see you in the 10th version in 2025. All the presenters will be getting their digital certificates through mail within 2 working days. Further, all the papers have already been forwarded to the Springer. The publication will be live within 6 months. Kindly cooperate to the team of ICICT 2024. I also thank our session chair, Dr. Anubhava Jain, for chairing the session.
Thank you, Harsh. Thank you, Karthik.
This is the
Thank you
token of
very much.
appreciation from Team ICICT and Global Knowledge Research Foundation and partners. Ma'am, kindly acknowledge our participants.
Yes, thank you very much. Everybody had delivered their sessions very well, and I wish them all the best for the future research. And I also thank GR Foundation team for organizing very good conferences yearly and periodically both. Thank you very much.
Thank you, ma'am. Now I request everyone to turn on their cameras for a quick virtual snapshot.
Hello.
I again request everyone to kindly turn on their
Give
cameras
me
for a quick
1 minute.
virtual snapshot.
Give me 1 minute. बंद कर रखा है. Give me 1 minute.
Okay, ma'am. Thank you, everyone. It was a
Okay.
great
Thank you. Have a nice
presentation.
day, everybody.
It was great. Stay connected, stay safe. Thank you. Take care.